So it all depends on delta naught and pairing energy, students. See, if the delta naught is so high, that is the difference between the T2g and the EG orbital is too high, then what happens is electron prefers to pair, because pairing also requires energy, because the electron will be kept at the same suborbital. Same orbital the electrons are kept at. That is the reason electron repulsion will be there, and also the electron's spin has to be changed. That means you have to keep always like this. So pairing also requires energy. That is what is called as pairing energy. One more thing is we have a delta naught. To put the electron on the T2g orbital, you have to rise the energy. Electron has to go here. That means electron will be destabilized because you are putting the electron on the higher orbital. Important thing, students, in coordination compounds, this part has to be understood very clearly. If the delta naught is too high, electron prefers to pair. If the delta naught is too small, then the electron will go to the higher energy. So in the case of this, delta naught is lesser than the pairing energy. Energy required to pair is higher than the delta naught. That means delta naught is very small in the case of this. Whereas in this case, in this particular complex, delta naught is greater than pairing energy. That means delta naught is too high that electron prefers to pair at the lower orbital rather than going to the higher orbital. That is the reason electronic configuration of this is delta naught is lesser than pairing energy. Electron will go to the higher energy. That means it is dxy, or I will write it like this straight away. T2G3, electronic configuration of this complex, I will write it here, students. T2G3 and EG1 is the electronic configuration. They may ask you the electronic configuration directly. And the electronic configuration of this complex is T2G4, EG0, because electron hasn't pumped into the higher energy orbital, rather it has paired in the T2G orbital in the case of the second complex. Now question is, what made the second complex to have electronic configuration this, or what made the second complex to pair and the first complex to not to pair and putting in the higher orbital? It all decided by here the ligand, student. That is, you have water ligand here and you have ammonia as a ligand. So ligand is the main factor, and also the central metal ion comes into the picture. Central metal ion also the factor, and the last one is the geometry is the factor. These three things will decide what has to happen whether electron has to pair or electron has to go to the higher energy orbital will be decided by the ligand, central metal ion and the geometry. What is the CFSE for this then? CFSE for this particular complex is, can we write it? CFSE T2G3, that is 3 electrons in the T2G orbital, 3 into minus 0.4 delta naught plus 1 into plus 0.6 delta naught plus 0.6 delta naught. That means this is 1 minus 1.2 plus 0.6, that is minus 0.6 delta naught. This is the CFSE. Whereas CFSE for this is minus 4 into minus 0.4 delta naught or minus 1.6 delta naught, minus 1.6 delta naught or minus 1.6 minus 16 dq, minus 16. If someone asks you which complex is stable, this or this, which complex is stable? This complex is stable because it is having a very high CFSE, minus 1.6 delta naught. That much energy has come down. Whereas this is having minus 0.6 delta naught. This is highly stable, this complex compared to this. So this we have predicted based on the CFS. Stability question will also come. We will take care of that. Don't worry about that. There are simple clues are there, shortcuts are there to predict all those things. Don't worry. Try to understand this. So I'll repeat again, students. Important, very, very important thing. Mainly it is decided by the ligand. Whether delta naught has to be higher than the pairing energy or delta naught has to be lower than the pairing energy. These two conditions will be decided by, one is ligand, second one is central metal ion. central metal ion. Third thing is geometry. Third thing is geometry. We'll take care of this one by one. Ligand. First one, we'll just take a look at the ligand first. Based on the ligand itself, we can speak number of things. In the first group transition elements, that means 3D series, we can speak only on the basis of the ligand. So when it comes to the, the different series, then only we have to consider the central metal ion. And the geometry is also an important thing. As far as the ligand is considered, the strength of the ligand speaks about whether the delta naught has to be higher than the pairing energy or delta naught has to be lower than the pairing energy. So this will be given by very important series at the beginning of the, the coordination compounds discussion. I have spoken about this, what is called as spectrochemical series. This series is important, which speaks about number of things. That is, the strength of the ligand will be spoken by what is called as spectrochemical series. If you understand the spectrochemical series properly, we will be able to understand whether it is a high spin complex or the low spin complex, whether it is outer orbital, inner orbital, geometry, hybridization, everything could be spoken by knowing the spectrochemical series in detail.